Somewhere in the ocean right now, a father is giving birth. Believe it or not, the male is actually in labor. That sentence alone is strange enough, but here's the part that makes it stranger. That's not the most extreme thing an ocean animal does for its young. And as you'll soon find out, it's not even close. Deep underwater, 4 animals take parental devotion to such an extreme that it stops looking like simple instinct and starts to look like something else entirely. So how far will an animal actually go for its young? And what does it mean when the answer keeps being further than we thought possible? Stay with me. Let's get one thing out of the way immediately. When it comes to seahorses, the male is the one who gets pregnant, not as a metaphor and not in a supporting role. In this unusual display, the female deposits eggs directly into a pouch on the male's body, where they are fertilized, carried, and eventually born. He experiences contractions, gives birth, and depending on the species, he can deliver up to 2,000 young in a single pregnancy. And in a world where the biological definition of male and female is largely built around which sex produces eggs and which produces sperm, the seahorse looked at that arrangement and apparently decided it wasn't working for him. Here's how it actually works. The female transfers her eggs into the male's brood pouch during an elaborate courtship ritual. Seahorses are one of the few animals that form pair bonds and return to the same partner day after day. Once the eggs are inside, the male fertilizes them and the pouch seals. His body begins supplying oxygen and nutrients directly to the developing embryos. His circulatory system essentially extends to support them. The pregnancy lasts between 2 and 4 weeks, depending on species and water temperature. During that time, the male continues moving, feeding, and functioning while carrying a brood that visibly distends his body. And when the time comes, he anchors himself to a piece of coral or seagrass and goes into labor. The contractions can last hours. He pumps and convulses until the young are expelled into the water, fully formed miniature seahorses, immediately independent, immediately on their own. He may be pregnant again within hours. And in some species, the same female is waiting. Most fish broadcast spawn, releasing eggs and sperm into open water and leaving. Seahorses return to each other. Every morning, they perform a greeting ritual, rising together in the water column, intertwining tails, changing color in synchronized patterns. It lasts several minutes. Then they separate for the day. The male carries the young, the female visits daily. By the standards of the ocean, this is an extraordinarily committed arrangement. Most fish never interact with their mate again after spawning. Seahorses come back the next morning. And the male does the hard part every time, every single time. I think about that every time someone tells me fish don't have complex social lives, which honestly happens more than you think. Jawfish is not a dramatic-looking animal, small, bottom-dwelling, unremarkable by most measures. It lives in burrows it excavates in sandy or rubble-covered seafloor and spends most of its life being inconspicuous. Nothing about it suggests what the male does when it's time to protect its young. So what's its deal? Well, what makes this ocean animal so extreme is that he holds his youth in his mouth. Not briefly, not as a quick protective measure. For 2 weeks, which, if you think about what that actually looks like, is one of the stranger images in this video. After the female lays eggs and they are fertilized, the male jawfish takes the entire clutch into his mouth and keeps them there. The eggs are rolled constantly with his tongue to keep them aerated and clean. He monitors them. He adjusts them. He keeps them alive through constant physical contact with his own body. And he doesn't eat. He can't close his mouth properly with the eggs inside. He can't hunt. He can barely function as a normal fish for the entire incubation period. If threatened, he spits the eggs out to be able to move freely, and then immediately goes back to retrieve every single one. Researchers filming jawfish have documented males collecting scattered eggs one by one from the seafloor after a threat passes, taking them back into their mouths and resuming incubation as though nothing happened. 2 weeks, no food, mouthful of eggs, and the moment something threatens them, he spits them out to escape, then comes straight back to collect every single one. An incredible act, nonetheless. The energy cost here is significant. The male jawfish enters incubation in reasonable condition and exits it visibly depleted. His body has been running on reserves the entire time. The moment the eggs hatch and the young swim free, he is immediately hungry, immediately weakened, and immediately at greater risk from predators because of it. And then, in many species, he does it again with the next clutch. The female may already be ready with another batch of eggs. He recovers for a matter of days before the cycle begins again. Over the course of a single breeding season, a male jawfish may go through this process multiple times, spending more time starving and incubating than he spends hunting and eating. What makes this different from simple instinct is the retrieval behavior. Retrieving scattered eggs one by one isn't a fixed action pattern. It requires the male to assess the situation, locate individual eggs, and make repeated trips until the clutch is complete. That's problem solving under stress. For a fish that's been starving for 2 weeks, and nobody taught him to do it. There's no learning period, no observation of other jawfish fathers. He just does it, which makes it more confusing, not less. Because if it's purely instinct, it's instinct sophisticated enough to look like something we'd call dedication in any other context. Meet the Discus fish, recognized as one of the more visually striking freshwater fish in the world. Flat, circular, patterned in vivid colors. It's popular in aquariums. Most people who keep them have no idea what the parents do for their young in the first weeks of life. Both parents secrete a nutrient-rich mucus through their skin, and the young feed directly off it. The moment they hatch, the young swarm the parents' bodies. They press against the skin and consume the secretion directly, the same way a mammal feeds from its mother. Both parents participate. The young move between them, feeding from one and then the other, while the parents remain still and allow it to happen. And I think that image, two fish holding still while their young feed directly from their skin, is one of the stranger things I've come across researching this video. This continues for weeks. The parents lose significant body mass during this period. They are being consumed slowly, continuously, by the animals they're trying to protect. Their own bodies become the food source. Researchers have documented discus parents losing up to 25% of their body weight during the brooding period. They eat during this time, but what they consume goes largely toward producing the secretion rather than maintaining their own condition. The chemistry of the secretion is remarkable. It contains proteins, fats, immunoglobulins, and growth factors, a nutritional profile genuinely similar in composition to mammalian milk. The discus fish evolved this independently, no common ancestor with mammals, no shared evolutionary history that would produce this outcome. Nature arrived at the same solution through a completely different path. Evolution ran the same experiment twice and got the same answer, which should probably make us more humble about how unique we think we are. What stops this from being purely mechanical is the coordination between the parents. If one parent needs a break, it signals to the other, and the young transfer across. Researchers have observed what appears to be a handoff behavior, one parent moving slightly away while the other positions itself for the young to follow. Whether that constitutes communication is debated. What isn't debated is that both parents are managing the process together at cost to both of them for weeks. Next on the list is the giant Pacific octopus, which lays between 20,000 and 100,000 eggs in a den she has chosen and prepared. She attaches them to the ceiling of the den in cascading clusters. And then she stays. For up to 7 months, she doesn't leave. 7 months in a den, all without eating. A truly remarkable act. She aerates the eggs constantly, running water over them with her arms, keeping them clean, keeping them oxygenated. She removes debris. She fends off predators. She monitors the development of each cluster. Researchers studying brooding octopus mothers have observed them performing this maintenance continuously, day and night, without rest. And in case it slipped your mind, she doesn't eat for 7 months. An animal that is, under normal circumstances, an active and aggressive predator, one of the most effective hunters in the ocean, stops hunting entirely. Her body begins consuming itself, muscle mass depletes, her color changes, her movements slow. By the time the eggs are close to hatching, she is visibly deteriorating. The final weeks are the hardest to read about. She begins showing signs of neurological decline. the same process of senescence that octopuses undergo at the end of their natural lifespan, accelerated by starvation. Some researchers have observed mothers in this final stage pushing their young out of the den with weakening arms, as if helping them into the water in a last coherent act before losing the ability to function entirely. Unfortunately, there's no happy ending as she never sees her young survive. The eggs hatch, the young disperse into open water, and she dies in the den, alone, depleted. Having given every resource her body contained to offspring, she will never know the outcome of. What makes it even harder to process is that this isn't the most extreme case we know of. There is a documented case of a deep-sea octopus, Granelodon boreopacifica, observed brooding a single clutch of eggs for 4.5 years, all passed without eating, the longest known brooding period of any animal. When the eggs finally hatched, she was gone within days. She had been guarding those eggs since before some of the researchers studying her had started their graduate programs, 4.5 years, in complete darkness at depth, without eating, for a single clutch of eggs. The researchers who first found her returned to check on her 13 times over that period. She was always there, always tending the eggs. When they returned for the 14th visit, the eggs had hatched and she was gone. So here's what this video has been building toward. Every animal on this list does something that survival logic alone can't explain. The seahorse male rewrites what a parent physically is. The jawfish father starves for 2 weeks and retrieves scattered eggs one by one from the seafloor. The discus fish parents become food for the animals they're protecting. The octopus mother gives her body, her hunting, her health, and finally, her life. For offspring, she will never see grow up. None of them chose this. None of them understood the cost before it started. None of them had a concept of sacrifice or devotion or love. They just did what their biology drove them to do, at a cost that kept being higher than it needed to be for the species to survive. And that's the part that stays with you, not the facts, the scale of it. Evolution is supposed to be efficient. It's supposed to produce the minimum investment necessary for offspring to survive. And yet, here are 4 animals making investments that go far beyond minimum. The octopus could guard fewer eggs and survive. The jawfish could eat during incubation and still hatch some of the clutch. The discus fish could feed their young other food sources. The seahorse male could have a shorter pregnancy. They don't. None of them do. The behavior in every case exceeds what the math of survival requires. And honestly, science doesn't have a clean explanation for why. We don't fully understand what pushes these animals this far. What we know is simple: it worked. The species survived. The behavior was passed on, and somewhere in the ocean right now, a male jawfish is holding his young in his mouth and hasn't eaten in 10 days. A discus mother is letting her offspring feed directly from her skin. An octopus is in a den she entered 7 months ago and hasn't left since. They're not doing it because they understand what it means. They're doing it because something in them won't let them stop. And the strangest part is that we call that instinct, as if giving it a name explains it, as if saying the word instinct tells us anything about what it actually is, or why it produces behavior this extreme, or why evolution kept selecting for it when less would have been enough. The jawfish could have evolved to eat during incubation. The octopus could have evolved a shorter brooding period. They didn't. Whatever this is, it runs deeper than efficiency. And we don't have a better word for it than the one we already have. Maybe that's the most honest thing this video can leave you with. Not an answer. Just the observation that 4 very different animals in 4 very different aquatic worlds arrived at the same conclusion independently. And I find that harder to dismiss every time I think about it, that their young were worth more than their own survival and acted accordingly. If you want to see a video about animals that channel that same relentless drive into something completely different, check out the one on the only 4 animals that actually hunt humans. Thanks for watching.